Assalamualaikum and hi. So in this video we are going to look at the dependence of the resistance, capacitive reactant, inductive reactant and also impedance on frequency and the relationship of it with a resonant. Okay, so resonant is defined as the phenomena that occurs when the frequency of the applied voltage is equal to the frequency of the RCL series circuit. So maksudnya bila frequency of the applied voltage ni sama dengan frequency of the RCL series circuit ini, kita cakap resonance occur. Okay, so now we are going to look at the dependence of all these reactant to the frequency. So kita ada XC dan juga frequency. Relationship dia kita dah tengok when we look at the capacitive circuit. We have an inversely proportional relationship sebab XC sama dengan 1 over 2 pi F C, where XC is inversely proportional to the frequency. And then when we look at the inductive reactant, dependence dengan frequency adalah directly proportional. This is your ini inversely proportional adalah XC, and then directly proportional adalah kamu punya XL, because we have equation XL is equals to 2 pi F L, they are directly proportional. And then untuk resistance, it is independent of the frequency. Resistance tidak bergantung kepada frequency. So when you combine all these three reactant, iaitu the resistance, the inductive reactance dan juga capacitive reactance, kita akan dapat impedance. Betul? Because when you have combination of circuit, bila kita ada combination of circuit, total opposition kita becomes impedance, where R square plus XL minus XC. So kita punya total opposition akan berlaku melalui this impedance. So secara overallnya, when we want to look at the impedance dependence on the frequency adalah you have to consider all these term yang ada dalam calculation ni lah. Berdasarkan calculation ini, kita akan dapat nilai-nilai dia as your frequency varies. So bila frequency dia berubah, kita akan dapat bentuk graf sebegini untuk impedance, total opposition kita, iaitu at this particular frequency dia adalah hasil gabungan resistance, inductive reactant dan juga capacitive reactant dekat sini. However, for the resistance, it is independent of the frequency kan. So lagi dua, kalau kamu tengok dia berubah-ubah tempat. Lagi dua ni dia berubah-ubah tempat. Therefore, you are going to have your impedance changes juga dekat sini. Okay, hasil gabungan semua reactant ini pada titik ini. Okay, so let's say at this particular F, okay, your inductive reactant berubah nilai ke sini. Okay, A contoh. And then capacitive reactant pula dekat B. Resistance masih dekat sini C. So now you're going to take the C resistance punya value, squarekan dia, campur dengan XL punya value which is A, tolak dengan XC punya value B, and then you squarekan, you square root, you can get the value of your Z dekat sini. So that is why you get this type of graph dekat sini. Alright, so at one particular point kita akan ada your XL dengan XC bersentuh, which means they are going to have the same value at this point. XL here is equals to your XC. XL sama dengan XC sebab mereka bersentuh, and at that particular point your impedance akan sama dengan resistance, sebab bila XL dan XC ini sama, you're going to get 0 here, therefore Z akan sama dengan R. This is where kita panggil the resonance occur. So frequency dekat titik ini kita panggil resonant frequency. Okay, alright. So when you have graph here, a few interpretation can be made. The first one adalah at low frequency, iaitu bahagian sini. Bila frequency kamu rendah, Z kamu besar, large, because dia punya capacitive reactant dia besar dekat sini. On this part, it is large lah kan. And then at high frequency pula, the impedance is also large because XL pula yang lebih besar sekarang. So bila kita ada XL besar, kita punya impedance pun besar. So as you can see, at low frequency dan juga high frequency, low frequency dan juga high frequency, you're going to have large impedance disebabkan oleh for low frequency XC kamu besar, untuk high frequency XL kamu besar. However, at resonant frequency, impedance Z is a minimum. Okay, sebab ini nilai paling kecil. Kalau kamu tengok ini besar kan, ini nilai-nilai besar dia. So this is the maximum value it can take. Therefore, the minimum value dia boleh ambil adalah sini, which is equals to your value of resistance. Okay, bila Z sama dengan resistance, it means that your XL is equals to XC. Okay, ini hanya akan berlaku at resonance sahaja. Okay, your I is maximum at resonance. So, beberapa benda yang kamu kena take note. At resonance, kita akan ada XL sama dengan XC. Ini benda pertama. XL akan sama dengan XC. Therefore, Z kamu akan sama dengan R and your Z is a minimum. Maksudnya, ini adalah opposition yang paling rendah you will have in the RCL circuit. Paling minimum lah kan. Therefore, your I becomes maximum dekat sini. Because when your opposition is low, okay, rintangan kamu rendah dekat sini, total opposition kamu low, maka kamu akan ada current yang paling maximum. Because I and Z is inversely proportional dekat sini. Okay, so with that we can have a graph of I versus frequency pula. I versus frequency ini akan terbalik dengan Z ini. Because as your Z is higher, your I is lower. Okay, as your Z reach paling minimum, your I akan reach paling maximum. So, bentuk graf ini sama, cuma terbalik sahaja. Okay, because according to the basic Ohm's law, V is equals to IR. Tapi kita punya case adalah kita ada combination of opposition. So, kita akan guna impedance dekat sini. From here, we can say I is inversely proportional to the Z. Okay. Alright, so sekarang kita nak cari resonant frequency. Apa nilai resonant frequency ini itself? So we are going to find that particular value. So for that, we are going to start with this known equation where your resonant can occur. XL is equals to XC. And we know XL adalah omega L. Omega adalah 2 pi FL. 2 pi FL dekat sini. Okay, and then XC pula 1 over omega C. And omega adalah 2 pi F. Okay, and we know XL equals to XC hanya akan berlaku at resonance sahaja. Therefore, frekuensi yang kita nak tulis dekat sini, kita tulis sebagai FR terus. And then you rearrange this equation to get the value of your FR. Your FR akan sama dengan 1 over 2 pi cert L darab dengan C, iaitu nilai inductance dan juga capacitance kamu ini. Okay, so this is your resonant frequency. So, this is the explanation at resonant. What is going to happen? Impedance kamu Z ni adalah hasil daripada R square campur XL minus XC. When you have XL is equals to XC, you get this summation here as 0. Therefore, Z kamu akan sama dengan R. Z ini kita panggil minimum. When your Z is equals to R, ini adalah Z yang paling minimum. Kalau tak percaya, tengok dekat graph ni itself. The value yang paling rendah your Z can reach adalah, because as you can see here, nilai Z adalah from here, dia patah balik naik sini. So, paling maximum dia adalah dekat sini. This is the maximum value. This is the minimum value for your Z. Okay, Z minimum occur at the value of the resistance. Okay, ini adalah relationship yang Miss cakap tadi lah. IRMS is equals to VRMS over Z. Therefore, I is inversely proportional to Z. So, bila Z minimum, I kamu akan maximum. Kita relate dua graf ni. Inversely. Alright, so that's it about the dependence of the resistance, capacitive reactance, inductive reactance, and also impedance on the frequency.